In Unit 16, Part 3, we're going to talk about how to find the surface areas of pyramids and cones. If you remember in 16, Part 2, I taught you guys as a group because we were looking at nets of prisms and cylinders, and I kind of walked you through that all together because that was a little bit more difficult. After doing that, Part 3 shouldn't be as tricky, but again, if you have any questions, feel free to ask. If you need to use the geo models, just let me know, and I can show you some of the geo models. So, a couple things we need to look at. First off, these pictures over here. This top picture is of a pyramid, and these bottom pictures of a cone. Hopefully you know that either from math or science or pyramid just from history class or whatever. So hopefully you know what the general shape looks like, but let's look at some specifics. So first, let's talk about the height of the pyramid. The height of the pyramid is the perpendicular distance between the base and the common vertex. So if you look at our picture over here, we have a vertex, which is where all the triangular sides meet, all the lateral sides meet at the top of the vertex, and then our height is that distance down to the base. Okay? The base of our example here is a square. It could be a rectangle. Actually, it could be a square or a triangle. Actually, it could be anything. But as we'll talk about in a second, we're only talking about regular ones to make it a little bit easier. So the vertex is the top point. The height is the distance from the top point down to the base. The lateral faces are all the triangles that make up the pyramid. They kind of fold up to make the pyramid. And then the slant height, if you look down here in red, the slant height is the height of any of the triangular faces. So when we talk about pyramids and cones, we're going to be talking about the slant height. Pyramids also have regular height as well, but the slant height is what's really important. So the slant height is this distance right here. It goes from the vertex down one of the lateral faces. As I mentioned, I talked about regular pyramids. If you look at this definition in green. So it says for a regular pyramid, the base is a regular polygon. Remember, regular means all the sides are the same length. And the lateral faces are congruent, isosceles, triangle. So what that means is our base is a square or a triangle with sides that are all the same. And then our faces are all congruent. They're all equal. Our lateral faces, all the triangles are equal. And they're isosceles, meaning two of the sides are the same. Okay, so we're only talking about regular pyramids. If you look down at the cone, okay, the height of the cone is the distance from the vertex to the center of the base. A cone has a circle for a base always. Okay, for a pyramid, it can be different shapes. For a cone, it's always going to be a circle. So the height of a cone, which they didn't even draw on here, is just from the vertex down to the center of the base. The slant height is then going to be this outside part, from the vertex to the edge of the base. So the next part of the notes, it asks you to find the slant height. So before we get into actually finding the surface area, we have to look at how to find the slant height, because we'll use the slant height when we find the surface area. So it says find the slant height of the pyramid or cone, round to the nearest whole number. So if you look at what you're given right now, 24 is kind of like the halfway line of our base, okay, or it's the base of that triangle that's drawn on there. 45 would be the height of that triangle drawn on there. If you finish out this triangle, so here's your height of the triangle, here's your base. If you draw the hypotenuse, we've created a right triangle. So we're going to use Pythagorean theorem to find our slant height. So it says find the slant height, round to the nearest whole number. So for our square pyramid over here on the left, our slant height would be 24 squared plus 45 squared equals c squared. We're looking for the hypotenuse as the slant height. 24 squared is 576. 45 squared is 2025. That's equals c squared. I add those together, I get 2601 equals c squared. And then if I take the square root of both sides, I'll get c equals 51. So my slant height is 51 centimeters. Okay, let's look over here at our cone. So again, we have the base of the triangle, we have the height of the triangle, we need the hypotenuse. So a squared plus b squared equals c squared. So a squared would be 6 squared, plus b squared would be 12 squared, equals c squared. So that's 36 plus 144 equals c squared. 36 plus 144 is 180. And we're going to take the square root. When we take the square root and round, we get 13 feet. So we're going to say our slant height is 13. So again, if you need to find the slant height, we're going to use the Pythagorean theorem. Okay, moving down to the bottom, it says, we're just going to, before I actually solve any, we're going to look at the formulas for pyramids and cones to find surface area. So, if you look on the left here, we have the surface area of a regular pyramid. Again, regular pyramid means the base has sides that are all the same length, and then all the lateral faces are isosceles triangles, and they're all equal. So it says the surface area S of a regular pyramid is the sum of the base area B and 1/2 the product of the base perimeter P and the slant height L. Okay, again, super confusing, but I'll give you these formulas when you're working on check-ins and stuff. You do need to write down that capital B is the area of the base. Okay, we talked about that in part 2. So it's the area of the base. Capital P is the perimeter of the base. And then this weird looking L is the slant height. Again, we find slant height by doing Pythagorean theorem. So that is for a regular pyramid. By looking over to the right and down a little bit, we have the surface area of a cone. So the surface area S of a cone is the sum of the base area B and the product of pi, the base radius R, and the slant height L. Again, really long definitions. This is actually shows you, this is the formula that I boxed in blue. What I boxed in red is really just the formula expanded. Okay? Remember, capital B stands for the area of the base. But we know for a cone, that's always going to be a circle. So if you look at the second equation, they just spelled it out for you. To find the area of a circle, you do pi r squared, and then it's going to be plus pi r times the slant height. So you're going to want to use this second, more dragged out formula when you find these surface areas. Before we practice using those formulas, let's look at nets. Okay, it says use the net with the solve to find its surface area, round to the nearest whole number. Okay, if you look at number 1, this is the net of a triangular pyramid. Okay. Triangular because the base is a triangle. That this middle one right here is a triangle, and then it's a pyramid because all the lateral faces are triangles as well. So if you look at this, they give us the area of the base. Okay, so we know that this base is 28. But we also know that these little tick marks mean all the sides are the same. So really, I just have 4 triangles that are all 28 inches squared. So to find the area, I can just do 28 times 4. When I do that, I get 112, and then that's going to be inches squared because I'm dealing with area. For number 2, this shows you the net of a cone. We don't really have a way to find this extra piece, so we're just going to have to use formula. So remember, our long drawn-out formula is S equals pi r squared. That's how you find the area of a circle. Plus pi r slant height. So pi is 3.14. The radius would be 11, because 22 is our diameter. We just set that half. So 11 squared plus pi radius, and then 18 would be our slant height. When we do 11 squared times 3.14, we wind up with 379.94 for our base for our circle. And then for the lateral face part, 3.14 times 11 times 18 is going to give us 621.72. When I add those together and I round to the nearest whole number, I get 1,002, and then it's going to be meters squared because we're talking about area. So if you look down here, we have two pyramids and two cones, so we're going to go over how to find the surface area for. Number one, I'm going to leave for you because we've already done some examples of square pyramids. I'm going to look at number two. Okay, so remember, my formula is surface area equals the area of the base plus 1/2 the perimeter times the slant. So that's my formula to find the surface area of the pyramid. So let's just spell it out. So surface area equals, I need to do the area of the base. My base for number two is a triangle. To do the area of a triangle, I do 1/2 base, which is 4. Base of the triangle is 4, times the height of the triangle, which is also 4. Okay. Now, if you look on this, okay, they actually made it even easier for you. They told you that the capital B is 7, so you don't even have to do that work. Okay, so B is 7. They've done that for you. Then we need 1/2 the perimeter. Okay, the perimeter of the base. This is my base right here. Okay, we know that it's congruent, so that's 4 plus 4 plus 4 will give me the perimeter of my base. And then my slant height they give to me is 6. So my surface area is going to be 7 plus 1/2 times 4 plus 4 plus 4 is 12 times 6. So if I want to work that out then, that's 7 plus half of 12 is 6 times 6, or 7 plus 36, and I'll get 43 yards squared. Okay? So the fact that they give you the area of the base makes it a little bit easier. So if you need to write down number 2, go ahead and rewind the video. Number 1, I'll leave up to you guys. Just follow the formula as you go along. For the cones, I'm also going to leave number 1 to you because that's a little bit easier. I'm going to do number 2. Let's review our formula. Surface area equals pi r squared plus pi r L. So now let's fill in. So pi is 3.14 times the radius squared. They give me the diameter, so I cut that in half. That would be 10 to the radius squared plus 3.14 times 10 times my slant height of 7. 3.14 times 10 squared is 314. 10 times 10 is 100 times 3.14 is 314. And then 3.14 times 10 times 17 is going to give me 533.8. When I add those together and round to the nearest whole number, I wind up with 848 meters squared. Alright, make sure you fill in any of the problems that I didn't do. If you have questions, just ask. If you need me to go through it with you for geomodels, feel free to ask that as well.